everyone, and welcome to this grade 9 mathematics lesson where we will be exploring factorization. My name is Miss Donnell Phillips. Let's get started. In the previous lesson, we explored the first three types of factorization, which were factorization using common factors, factorization by grouping, and factorization by using the difference of two squares. In this lesson, we will be exploring factorization of quadratic expressions. Now, what exactly is a quadratic expression? Generally speaking, factorization is the reverse of multiplying out. One important factorization process is the reverse of multiplication, such as this. So if we have two brackets to multiply, in the first bracket we have x minus 5, and in the second bracket we have x plus 3. When we multiply these two brackets, we would end up with x squared minus 2x minus 15. Here we have multiplied out two linear factors to obtain a quadratic expression by using the distributive law. To factorize a quadratic, we have to go from an expression such as x squared minus 2x minus 15 to the linear factors x minus 5 and x plus 3, which generated when multiplied out. In order for us to factorize a quadratic expression, we can use the AC method. There are 5 simple steps for us to follow in order to factorize a quadratic expression. First, we have to find the product of a and c. Second, we list all the products that equal to a times c. Third, we check to see if numbers listed equal to b when added. Fourth, we rewrite expression with the new numbers taking the b terms place. And 5, we group and factorize. Now we have an example at the top. We have the expression 8x squared minus 10x plus 3. Now the first rule says that we must first find the product of a and c. In this quadratic expression, the a term is 8, the b term is negative 10, and the c term is 3. So a times c would be 8 multiplied by 3. And when we multiply 8 by 3, we get 24. So the second step, we have to list all the products that equal to a times c. We pretty much just listen all the factors of 24. So we could have 1 multiplied by 24, we could have 2 multiplied by 12, 3 times 8, 4 times 6, negative 1 times negative 24, negative 2 times negative 12, negative 3 times negative 8, and negative 4 times negative 6. Here we have listed all the factors of 24. The third step, we have to check to see if the numbers listed equal to b when added. So the b term is negative 10. So from the list of all the factors that we have, we need to see which one, when we add it, would give us negative 10. So we're going to start from the top. 1 and 24, when we add them, we get 25. 2 and 12, when we add them, we get 14. 3 and 8, when added, gives us 11. 4 and 6, when added, gives us 10. Negative 1 and negative 24, when added, gives us negative 25. Negative 2 and negative 12, when added, gives us negative 14. Negative 3 and negative 8, when added, gives us negative 11. And finally, negative 4 and negative 6, when added, gives us negative 10. So we know that the only pair of factors that we have when added that would give us negative 10 is negative 4 and negative 6. So the fourth step, we have to rewrite the expression with the new numbers taking the b terms place. So when we rewrite the expression, instead of writing 8x squared minus 10x plus 3, we would now replace the negative 10x with the two new factors that we found. So we would have 8x squared minus 4x minus 6x plus 3. The fifth step, all we have to do is group and factorize. So we're going to group 8x squared and negative 4x, and then we're going to group negative 6x and 3. So what is common between 8x squared and negative 4x? We have 4x being common between them, so we put the 4x outside, we open bracket. 8x squared divided by 4x gives us 2x, and negative 4x divided by 4x gives us negative 1. On the next side, we have negative 6x and 3. What is common there? Negative 3. So you put a negative 3 outside of the bracket. Negative 6x divided by negative 3 gives us 2x. And 3 divided by negative 3 gives us negative 1. So if we look here, we could see that both brackets have the same thing. In the first bracket, we have 2x take 1, and in the second bracket, we have 2x take 1. Now, when we get to this step and we realize that both of the brackets have the same thing, then we know that we are in the right direction. The final step requires us to take what is outside of both brackets and put them in another bracket. So outside of the first bracket, we have 4x, and outside of the second bracket, we have negative 3. So when we put those two in a bracket, we have 4x take negative 3. So the first bracket, we have what is common in both brackets, 2x take 1. And in the second bracket, we have what is outside of both of the brackets, 4x take 3. So this is how we factorize quadratic expressions using the AC method. Now, if this wasn't clear for you, I am going to go through a few examples so that you would be able to grasp the concept. So the three examples that we're going to work are 2x squared take 5x take 3, x squared take 10x plus 21, and x squared plus 6x plus 9. So for the first example, we have to factorize 2x squared minus 5x minus 3. So the first thing we would need to do is identify our a value, b value, and c value. So we next need to calculate what AC is. Since A is 2 and C is negative 3, when we multiply the two together, we found that AC is equal to negative 6. The factors of negative 6, we're going to list them now. We could have 2 times negative 3. We could have negative 2 times 3. We could have 6 times negative 1 and negative 6 times 1. Now remember, in order for us to choose a pair, when we add these two numbers, we should get back our b term, which is negative 5. So now we're going to check and see which pair, when we add them, we're going to get negative 5. So 2 and plus negative 3 would give us negative 1. Negative 2 plus 3 would give us positive 1. 6 plus negative 1 would give us 5. And lastly, negative 6 plus 1 would give us negative 5. So we know that we're going to choose this pair, negative 6 and 1. The next step requires us to rewrite this equation, this expression. We're going to rewrite this expression. And instead of writing back negative 5x, we're going to use the two new terms, which is negative 6 and 1. So 2x squared minus 6x plus x minus 3. So from here, we could go ahead and we could group them. We're going to group these two first and factorize them, and then we're going to factorize these two next. So let's go. let's look at 2x squared and minus 6x. What is common? The 2 and the x, so we put it outside. Open bracket. 2x into 2x squared, we have x. And 2x into negative 6x, we have negative 3. So if we wanted to confirm that this is true, all we need to do is clear the bracket. 2, we write back the 2 because there is no number for us to multiply it by, and then x multiplied by x gives us x squared. So we did get back our 2x squared. Now 2 times negative 3 gives us negative 6, and there is no x to multiply, so we write back the x. So indeed, if we clear the bracket, we are going to get what we started with, which is 2x squared minus 6x. Let's focus on the next pair. We have x minus 3. What is common between the x and the negative 3? The only thing that could divide both of them is a positive 1. So plus 1, open bracket. X divided by 1 is x, and negative 3 divided by 1 is negative 3. At this point, we realize that both brackets have the same thing. This means that we are going in the right direction. In the next line, we're going to write what's in the two brackets, x minus 3, and then the terms that are outside of both brackets, we're going to put them in one bracket together, in one bracket. So we've written what's in both brackets. We're going to write them in this new bracket in front here. And then the other two terms that are in front of the brackets, we're going to put them in one bracket by themselves. So we have 2x, so we write 2x plus 1, and we close bracket. So when we factorize 2x squared minus 5x minus 3, we get x minus 3 into 2x plus 1. So here we have factorized this quadratic expression. The next example is x squared minus 10x plus 21. Again, we're gonna identify our a term, b term, and c term. So a 1, b negative 10, and c 21. So AC would be 1 times 21, which is 21. So we're going to go ahead and we're going to list all the factors of 21. We could have 3 times 7. We could have negative 3 times negative 7. We could have 21 times 1. And we could also have negative 21 times negative 1, because we know that whenever we multiply two negative numbers, we always end up with a positive number. So let's go ahead now and see. So the next step, we have to see which pair, when we add them, would give us negative 10. So 3 plus 7 gives us 10. Negative 3 plus negative 7 gives us negative 10. So right here, we realize that this is a pair that we're going to be replacing the b value with. So when we rewrite this equation, instead of writing negative 10, we will now replace negative 10x with negative 3x and negative 7x. So let's go. We now have x squared minus 3x minus 7x plus 21. All right, so we're going to factorize. We're going to group these and factorize them, and then we're going to group these two and factorize them. So let's look at the first pair. X squared minus 3x. The only thing that is common between these two terms would be the x. So you put the x outside, open bracket. X into x squared, x, and x into negative 3x would be negative 3. Good. Let's focus on the second pair. Negative 7x plus 21. We're going to use the negative 7, open bracket. Negative 7 into negative 7x would just be x. And negative 7 into 21 would be negative 3. We could check it back to ensure that it's actually correct. Negative 7 times x would give us negative 7x. And negative 7 times negative 3 would give us 21, positive 21. Here we realize that both brackets have the same thing, so that means that we are going in the right direction. We're going to rewrite what's in the two brackets first, x minus 3, and then in the second bracket we put what is outside both brackets. So this would be x minus 7. So when we factorize this quadratic expression, x squared minus 10x plus 21, we get x minus 3 and x minus 7. For our final example, we're going to factorize x squared plus 6x plus 9. So our a value is 1, our b value is positive 6, and our c value is 9. That means that AC is equal to 1 multiplied by 9, and anything multiplied by 1 would just be that number itself. So in this case, 9 times 1, 9. So we're going to list all the factors that would give, when we multiply them, would give us positive 9. So we could have positive 3 times positive 3. We could have negative 3 times negative 3. We could have positive 9 times 1. And we could also have negative 9 times negative 1. So these are all pairs. When we multiply them, they would give us they would give us 9. Now we need to see which pair, when added, would give us this b term, positive 6. So we could start from bottom. Negative 9 plus negative 1 would give us negative 10. 9 plus 1 would give me 10. Negative 3 plus negative 3 would give us negative 6. And 3 plus 3 equals 6. So this is the pair that we're going to be using to replace our x, our b term. So let's rewrite it. X squared plus 3x plus 3x plus 9. So we're going to go ahead, first pair that we're going to factorize, and then this is the second pair. So x squared plus 3x, going in common would be x. X into x squared, x. X into 3x, 3. So we're done with that. Next we have 3x plus 9. What is common? A positive 3. 3 into 3x, x. 3 into 9, 3. Both brackets have the same thing, so we rewrite that first. X plus 3 in the first bracket, and then what's outside of the bracket goes into another bracket. So we have x plus 3. Now, if we realize the two examples that we worked previously, both brackets had different terms. But in this example, both brackets are identical. In this case, because both brackets have the same thing, we call this factorization. We actually call this perfect square, because when we finish factorizing it, we found that both brackets have the same thing. So we could actually just rewrite this as x plus 3 all square. Right? So when we factorize x squared plus 6x plus 9, we get x plus 3 all square, and this is called a perfect square. So for your homework, you're going to try to factorize the following. Number 1, x squared plus 3x plus 2. Number 2, 2x squared plus 3x take 2. Number 3, 3q squared subtract 13q plus 4. And number 4, 8x squared take 10x take 3. So to summarize today's lesson, when we factorize a quadratic expression, we end with two linear factors in the form x subtract a and x plus b. And if we multiply the brackets, we will end up back with the quadratic expression that we started with. One simple way of factorizing quadratic expressions is by using the AC method. This has brought us to the end of this grade 9 mathematics lesson where we explored factorization of quadratic expressions. My name is Miss Donnell Phillips. See you next time.